Postulate is a statement or principle that is accepted to be true. It is also called axioms. And these are some postulates that can be related to the undefined terms that we have learned in our previous video. One of the postulates is the existence of points, wherein it says that a line contains at least two distinct points. So if there's a line, it contains not only one point, but at least 2 points. So this line contains point Q and point R as a known point. So it can be 3 points, 4 points, or infinite number of known points. While a plane contains at least three non-collinear points. So in this plane, this contain point Q, point Y, and point Z. So it may contain 4 points, 5 points, and so on. But it is impossible for a plane to contain only two known points, while a space contains at least four non-coplanar points. So this triangular prism, this contains point A, point B, point C, and point D. It is impossible for a space or a 3D geometry that contains less than four non-coplanar points. So for the line uniqueness postulate, given any two distinct points, there is exactly one line that contains them. So let's say we have a given point Q and point R. So there is only one line that passes through those 2 points. There's no other line except that line. For the plane postulate, it says that any 3 points lie in at least one plane. So we can use this revolving door as an example. So think this uh, part of the revolving door as our plane A. So in this plane A, it may contain, let's say, 3 points. So in this point B, it contains the same 3 points, which is contained in plane A. So it says that any 3 points lie in at least one plane. So it can be 2 planes, 3 planes, or 4 planes. So any three non-collinear points lie in exactly one plane. So if these points are non-collinear, so it means they are not arranged in a straight line. So let's say these points are uh, arranged like this. So they are non-collinear. So any three non-collinear points lie in exactly one plane. So these points only contained in plane A. It is impossible for these points to be contained in plane A at the same time in the other planes. Okay. So the fourth postulate is the plane intersection. So it says that if two distinct planes intersect, then their intersection is a line. So we will use the same revolving door. So think these two planes. So let's say this plane A uh, extended and up to these two planes behind these two uh, planes A and B. So if these two lines will intersect, their intersection is a straight line. Okay, for the fifth postulate, points on a line lie. So it says that if 2 points lie in a plane, then the line containing these points lie in the same plane. So let's say we have a plane P and there are 2 points that lies in it. So let's say the point Q and point R. If there's a line that contains these 2 points, it means this line also lie on the same plane P. Theorem is a statement that may be deduced from axioms or postulates of a system. So we know that theorem uh, are already proven, and this can be proven by using the axioms of postulates that we have learned a while ago. So we have here some basic theorems which are related to the postulates that we have learned a while ago. So the first theorem says that if two distinct lines intersect, then they intersect at exactly one point. So we will not show the proof of this theorem, but we will just illustrate them. So it says that if, let's say, we have two distinct lines here, the line L and the line M. So then their intersection is a single point. This one. For theorem number 2, it says that if there is a line and the point not on the line, then there is exactly one plane that contains them. So let's say there's a line L and there's a point A, wherein this point A is not on the line itself, but still there is common to them. They are or they lie in the same plane P. For theorem number 3, if two distinct lines intersect, then they lie in exactly one plane. So if we have here point L and point M, they intersect each other. So aside from this intersection, both of them are common in a plane wherein they lie. So in theorem number 4, it says that if a line intersects a plane not containing in it, then their intersection contains exactly one point. So let's say we have a plane and this line is not lying on the same plane. You can think of this plane as a target and this line as an arrow. So if this arrow hits the target, that hole is a single point. Okay, and that is considered as the intersection of the plane P and the line L.